Okay, today we're going to look at optimization. So we're going to try to maximize something or minimize something. So these will be real life examples. And the example we're going to do today is just making a box. Our box does not have a lid, it just has the bottom and it has 4 sides. And we're going to take a sheet of metal or a sheet of cardboard or something, and we're going to try to create a box that has the maximum volume, the biggest volume possible. So we're just going to cut out the corners. So the corners are just going to be squares. Okay, if we want to maximize the volume, the first thing we want to do is write down the formula for the volume. So the volume is going to equal the area of the base. So I'm just going to put length times width. That's the area of the base. And then times the height. In this case, the height is really easy to figure out. It's just the distance from here to here. All right, those are the sides. We're going to fold those up, and the height will just be x. Now for the area of the base, we're going to go ahead and take the green part to be the length. So that's usually the longer part. Doesn't have to be. And we're going to take the blue part to be the width. So that'll give us the area of the base if we multiply the length of the blue times the length of the green. Now let's do the length of the green first. You can see the entire piece here would be 73. But we're going to have to subtract x here. And we're going to have to subtract x here. So we're subtracting 2x. So the length is going to be 73, except you have to subtract 2x. Okay, and we're going to do something similar for the width. The entire distance here is going to be 41, but we are going to have to subtract off x here, and then another x over here. So we're subtracting off 2x. So our width is going to be 41 minus 2x. Okay, and now we're done. We have found the formula for our volume, and we can easily maximize this. Let's go ahead and do that with our graphing calculator. Okay, the first thing I'm going to do is I'm going to type in the function in y1. So I'll push green and then y equals. And I'm going to type that function in on y1. So I'm going to do parentheses times parentheses times parentheses. And then I'll go inside and type each thing. Okay, I do want to point out that you want to put a multiplication between each parentheses, or else you might get an error. So just be careful about that. Okay, so there's the function that we want to maximize. Let's go to the home screen. Now let's find where the derivative is 0. Remember, the max or min would have to happen at a critical number. So that's where our derivative is either 0 or undefined. This is a polynomial, so it will never be undefined. So we want to know where is our derivative going to equal 0, and that's where a max or min will occur. Okay, because I type my function in y1 of x, I don't have to type the entire volume function here. I can just put y1 of x. And I want to solve where the derivative is going to equal 0. So let me put equals 0, and then I got to go back and do the derivative. So I need to do the derivative of y1 of x. So what I typed in here was I'm solving this equation, right? It's where my derivative equals 0. And I'm solving it for x. You probably want to push green enter so you can get some decimal approximations. Let me write down my answer. Now we did get 2 critical numbers. However, we're going to have to throw away the 29. Because our smallest side is 41 and we're cutting out corners from both sides, our value of x is going to have to be less than half of 41. So our x is going to have to be less than 20.5. Because if we cut out x any bigger than that, we're not going to have any box left. So we cannot allow an x value of 29. So we're going to have to cross this out. So 29 is no good. The volume of our box, if x was 0, would just be 0. So that would give you kind of a minimum value. Let's figure out what the volume is at this spot right here. We're just going to do y1 of that number. Okay, I want to point out that I did type in the entire number, every single decimal of accuracy that I possibly could type in. And that's because if I use a rounded number and make more calculations, I'm going to have an error. We call that round off error. Okay, so the maximum volume would be 11,424.5069173. And that would occur if we cut out squares from each corner that are approximately 8.436 inches. Okay, for our second example, we want to minimize the distance between this exact point, 1, 1, and any point on this line, which we're going to call xy. You can see that it would be further over here, so this point would not be good. It would be further over here, this point would not be good. So our answer is probably somewhere around here. This looks like the shortest distance. First thing we're going to do is we're going to start off with our distance formula. Okay, there's our distance formula. We'll plug in the point 1, 1 and the point xy. And we're looking for the minimum distance, so we want to minimize this. However, we have a problem because we have a distance formula with an x in it and a y in it. But we can substitute our y for our function ln of x. And for most of these problems, the difficult part is going to be coming up with the equation that you want to maximize or minimize. And we just finished that. So the rest of the problem is going to be almost like example number 1, where we just solve where the derivative is equal to 0. So let's do that. I'm going to change my y1 function. Then I'm just going to go back to the home screen. I don't need to type it in again. I can type in the exact same thing. I want to solve where my derivative is 0. We'll push green enter. Now it's giving me two answers. It's giving me some equation, then it says or, then it gives me 1.4406. Let's write that down. Now if it gave you more than one critical number, you would have to plug each number into the distance formula and see which distance is the biggest and which distance is the smallest. Remember, we're looking for the minimum distance, so we want the distance that's the smallest. We only had one critical number, so this was a little bit easier. I'm going to truncate it, so I'm going to use 1.440. I'll ignore all the rest of the digits. You could also round it. It could be 1.441. That would be acceptable. But we do also want to find the y value. Remember, this point is on this function right here. So to get the y value, we're going to have to plug this x value into that function, and we're going to plug in every single digit of accuracy that we can, because we don't want round off error. So from the home screen, I'm going to clear it. I'm going to do ln of that number. It's giving me 0.365. So my y value is going to be 0.365, and that's the point on that curve that's the closest to the point 1, 1. Let's write it as a point, and there we go. Okay, for this example, we have two positive numbers. So we're going to call those numbers x and y. Those will be our two positive numbers. It says the sum of the squares of those numbers, so we need to square both of them and add them together, is 73. So we're going to say equals 73. We also want to find their maximum product. Well, their product is just going to be when you multiply those two numbers together, x times y. Now we do want to maximize this. Again, we have that same problem where we have an x and a y. That's too many letters. So we're going to solve this equation for y, and we're going to plug it in right here. We start by subtracting x squared from both sides, then we square root both sides. Okay, this is going to give you absolute value of y, and that's the same thing as plus or minus y. And we can move the plus or minus over to the other side. Now, because we know that y is a positive number, we can just choose the positive here. And now we can trade y for this square root right here. We can plug it into our product formula. Okay, there we go. That's the formula that we want to maximize. So we'll just type that into our y1, and we'll go back to the home screen, and we'll solve where the derivative is 0. I can just go up and grab that formula, push enter, and let's do green enter. You can see it's giving us two answers, a positive 1 and a negative 1. Remember, our x value was supposed to be positive, so we're going to choose the positive one. Okay, remember, always write down as many decimals of accuracy as possible, because you may need to use that number to make more calculations later. We do not need to figure out the y, because it just says find their maximum product. So we can plug this x value back into our product formula, and we can find that product. We'll go over to the calculator. Remember, we typed that product formula in y1, so from the home screen, we can just do y1, and then we can just go up and plug in that number, just push enter, and we don't need the x equals, so we're going to delete the x equals, push green enter. You can see that it's just giving us 36.5. Remember, that's not the y value, that's the maximum product. So the maximum product is going to be 36.5. And that's it. Okay, what we're trying to do here is we're trying to find the maximum area for a box that has two of its corners on the x-axis. It's going to have one of its corners here, one of its corners there. And the other two corners are going to be on this curve. The curve is called 5 cosine of x. So we need to figure out what is the maximum area that a rectangle could have in this situation. So let's do the area of a rectangle. The area is going to be length times width. The length is pretty easy. It's just the distance from the x-axis to the height right here, and that's just going to be y. So the length is just going to be y. The width is going to be the distance from the left side all the way to the right side. Now we do know that from 0 to the right side is going to be x. Cosine is an even function, so the distance from 0 to the left edge is going to also be x. So the total distance would be x plus x, so that would be 2x. So the width is going to be 2x, and the length is going to be y. But again, we have x's and y's, so we're going to need to trade the y for our function, which is 5 cosine of x. So that's the equation for our area. That's pretty much the hard part. Now we can just go to our calculator and do what we've done on all the previous problems. We're going to start by typing that equation in y1 of x. There we go. Go to the home screen. And again, we want to solve where the derivative is 0. We don't need to retype it. It's already there. Do green, enter. Okay, if you look at the graph, you can see that this is the number 2 right here. So we're expecting our x value to be a little bit less than 2. Now this answer looks good, 0.860. So you can see we got quite a bit of answers. We're going to plug in the one that makes sense. You'll notice I typed in all decimals of accuracy possible because I'm going to use this number and plug it back into my area function to find the maximum area. Remember, our area function was in y1, so we can just type into y1 from the home screen. And there we go. That would be our answer. That would be the maximum area, 5.610. Again, we're going to truncate our answer. So our maximum area would be 5.610. Remember, the AP test would also accept rounding, so you could say 5.611. That would also be acceptable. Okay, here's our last example. Okay, we have an example where one of our football players is trying to get to the football game as fast as possible. Right now, he's on a speedboat. The speedboat can go 37 miles per hour, and his friend is waiting in a car, but the car can go faster. It can go 45 miles per hour. So we're trying to figure out, what should the guy do? Should the boat go straight to the game? Would that be the fastest way? Or should he meet his friend somewhere along the way, get in the car, and then drive to the game? So what would be faster? Okay, there's a couple of things that are given. You can see the distance from shore is 200 miles, and the distance to the game is 700 miles. The speedboat can go 37 miles per hour, and the car can go 45 miles per hour. Again, we're trying to get to the game as fast as possible, so we want to get there in the shortest amount of time. So we're going to set up an equation for time. The total time, which we're calling capital T, is going to equal the time for the boat plus the time for the car. Now, you might remember from physics that distance is going to equal rate times time. And we're going to solve this equation for time. So we just divide both sides by r. So time is going to equal distance divided by the rate. So we're going to have time 1 and time 2. Time 1 is for the boat, time 2 is for the car. If you plug both of those things in, you replace the t1 with d1 over r1, and you replace the t2 with d2 over r2. Now it's kind of funny, if you look right here, it says r2, d2. Okay, now we're going to go ahead and plug in all the information that we know. We know the rate for the boat is 37, so we can plug that in. We know the rate for the car is 45, so we can plug that in. The distance for the car is going to be this distance here, so it's 700, but then you have to subtract the x. So for the d2, we're going to put 700 minus x. For the last one, you have this triangle, and you can solve for d1 if you do x squared plus 200 squared equals d1 squared. Because it's a right triangle, you can use the Pythagorean theorem. Okay, to solve this, we're just going to do the square root on both sides. We know d1 is a positive distance, so we're going to take the positive square root. And that's it. We now have our equation that we can minimize. So let's plug this into a graphing calculator and see what we get. We're going to type that equation on y1. Then we'll go to the home screen and we'll solve where the derivative is 0 to get our critical numbers. Now the calculator is giving us this number for our critical number, but we got to be careful. Is that the answer? Is that what they're asking for? Well, they want to know how far from the game should you come ashore. So what they're asking for is this distance right here. So they're asking for d2. The value that we just figured out was x. So we figured out this distance over here. But we need to figure out d2. So d2 is going to be the entire distance, 700, minus our x value. You plug that in a calculator, you're going to get 411.0785. So that's how far from the game that you should come ashore to arrive at the game in the fastest amount of time.